Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on force exerted by the jet on a stationary curve plate at the center. So we have derived the equation for this concept in our last video lecture. So based on that, we'll solve this problem. The problem here we have taken a jet of water of a diameter 50 millimeter moving with a velocity of 40 meter per second and strikes a curve plate, symmetrical plate at the center. Find the force exerted by the jet of water in the direction of jet. And we need to also consider that if the jet is deflected through an angle of 120 degree at the outlet of the curve plate. So this is the deflection angle given at the outlet of the curve plate. So first of all, for this question, let's try to draw a diagram for this. So first of all, then we can identify how to find out the force exerted by the jet of water. Suppose here a jet of water which is flowing with a velocity 40 meter per second. We can consider this, or let consider in straight line. Okay, so suppose this is the velocity of water which is flowing and with a velocity of 40 meter per second. This is the V 40 meter per second. This is the jet of water. Okay, this is the jet of water and which is striking a curve plate, which is striking a curve plate. Let the curve plate is like this, and this curve plate is fixed. Here you can see the curve plate is given stationary. So stationary means nothing but it is fixed. So this is in fixed condition. Okay, and this next one is this one. Okay, so fixed means in this both sides. Now the second one is it is given the jet is deflected through an angle of 120 degree. Normally we have seen this jet of water or jet of liquid or fluid is striking the plate, striking the curve plate at the center. Suppose this is the center point. Okay, and the plate is symmetrical, because that is the same thing is given, symmetrical plate, and which is striking at the plate at the center. Okay, now at the center if it's striking, then what about the water which will exist from this plate? It will existing from here to like this, and here also at this at the other end, other side also it will exist like this. So if you measure the angle of this jet from this plate with respect to the jet speed or the jet directions, so you can get an angle. Suppose let me draw, this is the, okay, this is the diagram. So now we can see the jet of water and the plate through which the water is coming out. This is inlet part, we can say this is inlet, and this is about the outlet from the plate. And if you measure this angle is nothing but theta. This angle is nothing but theta. So how we got this one? If you see in our previous derivations, and this is how the velocity which is coming out, which makes an angle of theta here. So the same theta I have taken here. But here in the question it is given the jet is deflected through an angle. So deflection angle is different actually. Deflection angle is this one, the angle of deflection. Okay, this jet of water which is deflected with respect to the jet flow in the x direction. So this is actually deflection angle, and that is nothing but 180 minus theta. So we need to find out what is the force exerted by the jet of water in the direction of jet. This is the direction of jet, correct? This is the direction of jet, not this one. After striking, due to the curve plate, it was inclined and it is moving through this one, but jet direction is this one. So we need to find out the value of Fx, the force exerted in the x direction. So for this, let's see what are the data given. So first of all, we can see the data given here. Diameter of the jet is given, dia d equal to, this is 50 millimeter, and this one we can convert into 0.05 meter. And similarly, the velocity of this fluid is given 40 meter per second. Strikes above the curve plate symmetrically at the center, and the angle of deflection is given. Angle of deflection given, that one we can write. This is angle of deflection. So angle of deflection is given. This is 1, 20 degree. Okay. Find the force exerted by this one. So we know that the formula of force Fx equal to rho a v square, square bracket start 1 plus cos theta. Okay, this is not the theta actually. Theta is another one, this one, and this 120 degree angle, that is nothing but the angle of deflection, this one. So this equal to 120 given. Okay, now so in this equation, if you see what are the unknowns are there, rho value, rho is nothing but density of the fluid, which you know that here water part is given, so we can consider the density of the water. Area you can calculate from here, diameter given, so area we can calculate pi by 4, this is d square, so we can get the value of area here. Now v is given in the question, and 1 plus cos theta. Theta we need to identify. So first two things we'll identify, one is area and another one is theta. So theta we can identify from here, 180 minus theta equal to 120 degree. So theta equal to, we can consider this is 60 degree angle. Okay. Similarly, area also you can calculate from here, like pi by 4 d square. So d is nothing but 0.05 square into pi value divided by 4, 0.00196. So this one you can consider 0.00196. This is the area of the jet. This must meter square. Now just put the value of all these things in this equation, like density equal to 1000, area equal to 0.001963 into velocity square. This is 40 square into bracket start 1 plus cos 60 degree. Okay, so this is the thing. So now we can multiply here. Again, we need to take the help of this. This must multiply 1000. Again, multiply 40 into 40. 3141. So this much is 3141 point, which is, I hope 5 is there. Yeah, 59 into 1 plus cos 60. So let's see, multiply bracket start 1. Okay, now we'll do one thing, otherwise first we'll go for the cos 60. So trigonometric value cos 60, this one, plus 1 into this. Okay, so directly we got this value 4712. So no need to again put the value here. Directly I got the value 4712.38 something we got. So this is the final answer of this. So let's write down this one. Again I'll write this is cos 60, and finally I'll write this Fx equal to 4711.388. 4711.388, this much Newton. So this is our required answer. So I hope you understand this problem, how to solve it. Is very, very simple actually. Nothing is there to confuse this much. This is only the single formula we are going to use to find out the force exerted by the jet of water in the direction of jet. Okay. So still, if you are having any kind of doubt regarding this, you can give a comment on the comment box. Thank you all.